I wasn't looking for underground chambers when I first walked into that brewery basement in Prenzlauer Berg. I was researching 19th century urban infrastructure, standard architectural history, the kind of documentation work that fills university archives but never makes headlines, sewer systems, water mains, the unglamorous foundations that made modern cities possible. But then the owner showed me the lagering cellar and I stopped taking notes, because I was standing 18 meters underground, in a chamber carved from solid stone, built according to the plaque on the wall in 1842. 18 meters. Read that again. Not a shallow basement, not a cellar excavated to the water table. 18 meters down through soil that every geological survey of Berlin describes as nearly impossible to work with. The city sits in an ancient glacial valley, former marshland. If you dig a hole anywhere in central Berlin, you hit groundwater at 2, maybe 3 meters. Below that, the soil turns to what modern engineers call subterranean quicksand, alluvial sandstone so fine and waterlogged that it flows like liquid when disturbed. Tunneling through it requires constant pumping, steel reinforcements, modern dewatering technology. Yet here I was, standing in a chamber from 1842, bone dry, perfectly ventilated, stone walls cut with precision that looked machined rather than hand-carved. And when I asked how they built it, the owner shrugged. The breweries were the pioneers of the Berlin Underground, he said. As if that explained anything, that phrase. The pioneers. It appears in every historical account of Berlin's subterranean development. The breweries needed deep cellars for beer fermentation, so they dug them. Simple necessity, nothing mysterious, except when you start measuring what they supposedly accomplished with hand tools and soil that modern equipment struggles with, the simple explanation stops making sense. I went back to the geological reports. Berlin's foundation is unstable, unpredictable layers of sludge, peat, and more soils left behind by ancient glaciers. Construction projects even today encounter problems that require sophisticated engineering solutions. When they built the Reichstag in the 1890s, workers had to drive 2,232 wooden piles 15 meters deep just to stabilize the subsoil for the dome's foundation. They used steam hammers, industrial equipment, crews working in shifts, and that was in the 1890s, with modern tools. For 15 meters, the brewery cellars went deeper, 18 meters in some cases, built in the 1840s, with hand tools. Think about that. But it wasn't just one cellar. I started documenting every underground structure I could find that predated Hobrecht's official sewer system. Prenzlauer Berg, multiple brewery cellars extending 15 to 18 meters underground, built 1840 to 1845, all in neighborhoods where the water table sits at 2 to 3 meters. Kreuzberg, similar structures, same depth, same period, same impossible soil conditions, all of them perfectly dry, all of them with ventilation systems that somehow managed air circulation without mechanical equipment. And all of them with load-bearing vaults that showed engineering sophistication that supposedly wouldn't exist in Berlin for another 30 years. The temperature in these chambers stayed constant year-round, perfect for beer fermentation. But the cooling wasn't passive. The chambers maintained specific temperatures, between 7 and 9 degrees Celsius, regardless of season. In summer, when surface temperatures hit 30 degrees, the chambers stayed cool. In winter, when everything froze, they never dropped below 7 degrees. Nobody explains how hand-dug cellars in the 1840s achieved temperature regulation that modern systems struggle to maintain. The official history of Berlin's underground infrastructure begins in 1873. That's when James Hobrecht, a Prussian civil engineer born in 1825, started construction on what would become Berlin's revolutionary radial sewer system. Hobrecht had studied in London and Paris. He returned to Berlin with plans for something ambitious, 12 separate drainage networks, each with its own pumping station connected by underground channels that would eventually stretch hundreds of kilometers beneath the city. The project began in 1873. By 1877, the first 80 kilometers were operational, connecting 2,415 buildings to the new system. By 1893, the entire network was complete. Historians describe it as revolutionary. Moscow, Alexandria, Cairo, Tokyo all adopted variations of Berlin's radial sewer design. But here's what caught my attention about the timeline. Those brewery cellars in Prenzlauer Berg and Kreuzberg, built 1840 to 1845, Hobrecht's revolutionary system, started in 1873, 30 years later. So who taught the brewery builders how to work in soil that supposedly required technology that wouldn't exist for another 3 decades? I found construction photographs from the 1870s, images taken during Hobrecht's sewer installation, workers standing in trenches, surrounded by pumps, working continuously to keep groundwater from flooding the dig sites. Shallow trenches, 3, maybe 4 meters deep, and they needed industrial pumping equipment running constantly just to keep them dry enough to work in. Yet somehow, hand tools in the 1840s managed 18 meters? The math doesn't work, unless the 1840s builders had access to something the official timeline doesn't acknowledge. When I started reading Hobrecht's own technical publications, his reports from the 1870s and 1880s documenting the sewer construction, I found something strange. He described everything in meticulous detail: pipe specifications, pumping station designs, sewage field layouts, page after page of precise engineering documentation. The 1884 publication, Die Kanalisation von Berlin, runs to hundreds of pages. Hobrecht documents pipe diameters, gradient calculations, pumping capacities, sewage field soil compositions. He includes tables showing projected water flow rates for different rainfall scenarios. He specifies the exact brick types used in pumping station construction. He even documents the paint colors for facility interiors. But when it came to the actual underground excavation methods, the techniques for working in Berlin's notoriously difficult soil, the systems for managing groundwater during construction at depth, vague references, modern construction techniques, specialized foundation work, methods developed during preliminary surveys, no specifics, no diagrams, no step-by-step procedures. For an engineer who documented paint colors, the absence of excavation methodology is conspicuous. I found one brief mention in that 1884 publication. Hobrecht noted that earlier underground infrastructure provided valuable reference points for the current project. Earlier infrastructure. One sentence. No elaboration, no description of what this infrastructure was, when it was built, or who built it. But he wasn't talking about the brewery cellars. The timeline doesn't match. The locations don't align. He was talking about something else, something already down there when his workers arrived. In 1891, the Allgemeine Elektrizitätsgesellschaft, AEG, attempted to build Berlin's first underground railway system. They constructed two test tunnels, the AEG test tunnel and the Strellauer Spree tunnel. Contemporary engineering journals called them innovative masterpieces. Both tunnels broke through into chambers that shouldn't have been there. The construction reports mention earlier construction and pre-existing ventilation shafts connecting to unknown origin points. The project never got built. The contract went to Siemens instead, who opened Berlin's first operational subway at Potsdamer Platz in 1902. When Siemens built their line, the public construction reports made no mention of pre-existing chambers. But I found internal correspondence from 1900. A letter from a Siemens engineer to a city planning official mentioned utilizing existing foundation work and accessing established underground routes. The letter noted that this reduced construction time significantly. It also noted that public reports should emphasize modern German engineering rather than inherited infrastructure. The official history emphasizes modern German engineering. The inherited infrastructure disappeared from the narrative. I visited the radial system, one of Hobrecht's original pumping stations, built in the 1870s by architect Richard Tettenborn. The building above ground is impressive, red brick Gothic style, large windows looking into clean, bright spaces housing gleaming machinery. Hobrecht insisted that his sewer system should be elegant. Clean and elegant, he wrote, the machinery visible, the engineering displayed. But it was the foundation chamber that stopped me. The chamber extends deep below the building, stone-lined, precisely cut. And here's the detail nobody mentions on the official tours. The stonework doesn't match the building above it. Different cutting techniques, different tool marks, different aging patterns. The chamber predates the 1870s structure. When I asked about it, the guide gave me the standard answer: repurposed quarry stone, or earlier foundation work. But the chamber wasn't built from repurposed stone. It was carved in place, a single continuous excavation, and it was already there when Hobrecht's workers arrived in 1873. I found engineering notes from that year. Internal documents marked internal reference only. Workers had encountered unexpected underground structures during initial excavation. They'd broken through into pre-existing chambers that simplified foundation requirements for several pumping stations. Pre-existing chambers. The notes didn't specify who built them or when. One entry described advanced drainage systems already in place. Another mentioned precision stonework that allowed construction to proceed faster than projected. By the 1880s, public reports stopped mentioning these discoveries. The official narrative solidified. Hobrecht designed and built a revolutionary system from scratch. German engineering triumph. Nothing inherited, nothing mysterious. The pre-existing chambers were edited out of history. During World War II, Berlin's underground became a refuge network. Bunkers, escape tunnels, storage facilities, all built or repurposed during the 1930s and 1940s. After the war, the Berliner Unterwelten Association began documenting this hidden history. They run tours through bomb shelters and Cold War tunnels. But there are sections they won't show the public. I spoke with one of their researchers. Off the record, he mentioned anomalous chambers encountered during early documentation efforts, spaces that predated World War II by decades, maybe longer. The problem, he said, is we can't establish clear construction dates. The stonework doesn't match any known period. The access points were sealed deliberately, and there's no documentation. I asked what they did with those discoveries. We noted them in internal reports, but we don't include them in public tours. People want to hear about the war, about divided Berlin. They don't want confusion about chambers that shouldn't exist. The confusion gets filed away. The public gets the simplified version. The chambers remain buried. Berlin today has the largest district heating network in Western Europe. 1,600 kilometers of underground pipes delivering heat to over 1.3 million households. The system uses cogeneration plants, facilities that produce both electricity and heat simultaneously, then distribute it through an underground grid. It's efficient, reliable, a triumph of modern planning. The official timeline says it began in 1920, but when I started mapping the network, tracing the pipes, following the distribution nodes, examining the foundation chambers, I kept encountering those familiar structures. The chambers from the 1840s, the infrastructure Hobrecht inherited in the 1870s, the anomalous spaces the Berliner Unterwelten researchers won't discuss. They align, not approximately, exactly. The brewery cellars from 1842 sit at regular intervals along what are now major heating distribution routes, specifically locations where the groundwater table is slightly lower, where the soil composition is more stable, where the glacial deposits create natural corridors for underground construction. As if whoever built those cellars in the 1840s already knew where underground infrastructure would work best. The modern heating grid follows the same routes, not because engineers in the 1920s were copying brewery layouts, but because both systems, separated by 80 years, were tapping into something older. A grid nobody admits exists. I found one more document, a municipal infrastructure planning report from 1925. It discussed the proposed district heating system and noted ideal locations for thermal distribution based on existing underground access points. The report included a map. The existing underground access points matched the 1842 brewery cellar locations. Exactly. Not in the general vicinity, not roughly aligned, exactly the same coordinates. As if whoever planned those cellars in the 1840s already knew where a heating grid would need to be 80 years later, or as if both systems were built on top of something neither timeline acknowledges. The 1925 report was filed and forgotten. The modern heating grid was built along those routes. And the connection between the 1840s chambers and the 1920s infrastructure disappeared from official history. Now, consider what we're asked to believe. In the 1840s, brewery workers using hand tools somehow excavated chambers 18 meters deep through soil that modern engineers call nearly impossible to work with. They did this without industrial pumping equipment, without steel reinforcements, without any of the technology that wouldn't exist for another 50 years. And they happened to place these chambers at precisely the locations where underground infrastructure would later prove most viable. Then, in 1873, James Hobrecht arrived and built a revolutionary sewer system. He encountered pre-existing chambers, advanced drainage systems already in place, precision stonework that accelerated his construction timeline. But the public reports emphasized modern German engineering. The inherited infrastructure was edited out. Then, in 1891, AEG built test tunnels and broke through into chambers with ventilation shafts connecting to unknown origin points. Then, in 1902, Siemens built the subway by utilizing existing foundation work and accessing established underground routes. But public reports omitted those details. Then, in 1920, the district heating network was planned using existing underground access points that perfectly match locations from 80 years earlier. None of this is speculation. These are documented facts from construction reports, engineering publications, and internal correspondence. What makes them strange is the pattern. Chambers appearing before the technology to build them supposedly existed. Infrastructure mysteriously simplified by pre-existing work. Official reports consistently removing these details from public accounts. And a modern system that follows routes established decades before anyone admits those routes existed. Not coincidence, not random variation, not independent anomalies that happen to align. Pattern. Ask yourself this. If Berlin's soil is so difficult to work with that the Reichstag needed 2,232 wooden piles driven 15 meters deep in the 1890s with steam hammers and industrial equipment, how did hand tools in the 1840s manage 18-meter chambers? If Hobrecht's 1873 sewer construction required constant industrial pumping to keep shallow trenches dry, what technology did the 1842 brewery builders used to keep deeper chambers bone dry. If the soil composition is unpredictable and nearly impossible to tunnel through, how did multiple construction projects across different decades all discover the exact same optimal routes? Unless, of course, the routes were already there. Unless the chambers were already mapped. Unless what we're seeing isn't independent construction projects, but successive generations building on top of infrastructure that predates all of them. The modern district heating network serves 1.3 million households. When you turn on your heating in Berlin, the warmth flows through pipes that follow routes established in the 1920s, which align with chambers from the 1840s, which connect to stonework that predates the official timeline. The engineers who built the 1920s grid knew it. The construction logs reference existing access points. The engineers who built Hobrecht's 1870s sewers knew it. Internal notes mention pre-existing chambers and advanced drainage systems already in place. The workers who excavated the 1840s brewery cellars knew it, because 18 meters down through impossible soil doesn't happen by accident. But the official history pretends each project started from nothing. German engineering, modern planning, systematic development beginning at documented dates, no inheritance, no mysteries, no questions. And the chambers that shouldn't exist, filed away in Berliner Unterwelten's internal reports, sealed with concrete during renovations in the 1950s and 60s, edited out of construction histories, forgotten, or at least we're supposed to forget them. I kept one photograph from that first brewery visit, the stone wall 18 meters down, tool marks visible in the dim light, precision cuts that looked machined rather than chiseled, and in the corner of the frame, barely visible, a drainage channel carved into the floor. It doesn't connect to any beer-making equipment. It doesn't drain to the surface. It slopes downward, deeper. Toward chambers, the owner said, it didn't exist anymore. Filled in during building code updates. Concrete poured into spaces nobody needed. When I asked if I could see the filled sections, he changed the subject. When I asked if he had the building's original construction plans, he said they were lost in the war. When I asked about the drainage channel, he said it probably connected to old groundwater management systems. Probably, maybe, lost. The same answers every time. I tried other breweries, other cellars. The pattern repeated. Do you have the original construction documentation? Lost in the war. Lost during renovations. Destroyed in a fire in 1962. Never kept records that far back. Different buildings, different owners, same erasure. Municipal archives had building permits from the 1840s. The permits note cellar construction and list costs, but the technical specifications, the engineering drawings, the method of excavation, not in the files. One archivist told me the detailed construction documents were stored separately from the permits. They would have been in the technical archives, she said, but those were moved to a different facility in 1938. The building was destroyed during the war. The permits survived. The specifications didn't. At the Berliner Landesarchiv, I found references to a collection of 19th century underground construction documents. The catalog described engineering drawings, excavation reports, and foundation surveys from the 1840s to 1860s. The catalog entry was clear. Collection relocated 1955. Contents transferred to state archives. When I requested access, the response was apologetic but firm. Collection status unknown. Materials cannot be located in current holdings. Relocated, transferred. Cannot be located. The pattern extends beyond Berlin. I contacted archives in Hamburg, Dresden, Leipzig, any city with similar underground brewery infrastructure from the same period. Hamburg. Records lost during 1943 firebombing. Dresden. Documentation destroyed 1945. Leipzig. Collections dispersed. Current location unknown. The cities that would have had comparable engineering challenges. The cities that would have had to solve the same groundwater problems. The cities whose records might have explained the techniques. All lost, all destroyed, all unknown. Berlin sits on top of itself. Layers built on layers. Each generation constructing on foundations they didn't fully understand, inheriting infrastructure they can't quite explain, following routes established by someone who came before. The official timeline gives us neat dates. 1842, breweries. 1873, sewers. 1902, subway. 1920, heating, clean progression. Primitive to advanced, simple to complex. But the chambers tell a different story. They tell of precision that predates the tools supposed to have created it. Of drainage systems that solved problems decades before those problems officially existed, of underground routes discovered and rediscovered across generations, then systematically removed from public records, of a grid beneath Berlin that nobody admits was inherited. Because if we inherited it, someone built it before us. And if someone built it before us, that someone had technology we don't acknowledge, and knowledge we've agreed to forget. The chambers remember, even if the official history doesn't. The stone walls 18 meters down, the ventilation shafts connecting to unknown origins, the drainage channels sloping toward spaces that shouldn't exist, all waiting beneath the city, all filled with concrete now, or sealed, or edited out of documentation. But the roots remain. And every time someone turns on their heating in Berlin, drawing warmth from a network that follows paths established before anyone admits those paths existed, they're tapping into something older than the history we were given. Something built by someone we've agreed not to remember. Something that works too well to be forgotten, even as we pretend it was never there at all.